Good evening. Tomorrow, November 19th, we stand on the precipice of what may be one of the most extraordinary moments in the history of human civilization. At precisely midnight GMT, NASA and the European Space Agency will release the first high-resolution images of the interstellar object designated 3I, Atlas. And I must tell you, the whispers coming from the scientific community suggest we are about to witness something that will fundamentally challenge our understanding of our place in the cosmos. Now, I want to take you on a journey this evening, not just through space, but through the implications of what we're about to see. Because this isn't simply about a curious object passing through our solar system. This is about confronting a question that humanity has asked since we first looked up at the night sky. Are we alone? Let me set the scene for you. 3I, Atlas, was first detected on October 15th, 2024, by the Atlas survey system in Hawaii. At the time, it appeared to be nothing more than another interstellar visitor, only the third we'd ever confirmed after Oumuamua in 2017 and Borisov in 2019. But within days, something became apparent. This object was behaving in ways that defied every model we had for natural cosmic debris. You see, when something travels through interstellar space, when it crosses the vast emptiness between star systems, enduring temperatures just above absolute zero, bathed in cosmic radiation for potentially millions or even billions of years, it should look a certain way. It should behave in predictable patterns. Comets outgas, asteroids tumble, ice sublimates. We understand these processes with extraordinary precision. 3I, Atlas does none of these things correctly. The first anomaly was its trajectory. Professor Avi Loeb at Harvard, a man I've had the privilege of debating and collaborating with over the years, immediately noticed that this object was not following a hyperbolic path shaped purely by gravitational forces. There was acceleration, non-gravitational acceleration. Now, for a comet, this wouldn't be surprising. The rocket effect of sublimating ice can push these objects around. But 3I Atlas shows no cometary activity, no tail, no coma, no outgassing signature that would explain the forces acting upon it. The second anomaly was its colour, and this is where things become truly peculiar. When you observe distant objects in space, you measure their light across different wavelengths, their spectral signature. This tells you what they're made of, how old they are, what kind of radiation environment they've been exposed to. Objects that have been floating through interstellar space for millions of years should be red. The constant bombardment of cosmic rays, the weathering effects of interstellar medium, all of this darkens and reddens surfaces over time. We see this everywhere we look in the cosmos. 3I, Atlas is blue, not slightly blue, intensely, impossibly blue. The bluest object we've ever observed beyond Earth's atmosphere. When the initial spectroscopic data came back, 3 separate teams verified their instruments because they couldn't believe what they were seeing. This is a colour that suggests either a pristine surface that has never been exposed to space weathering, or a composition that makes absolutely no sense for a natural object. The third anomaly is its shape. Now, we don't have perfect resolution yet. That's what tomorrow's images will provide. But radar observations from Arecibo and the Deep Space Network have given us a silhouette, and it's not what we expected. It's elongated, yes, but with a regularity that's deeply unusual. The ratio appears to be something close to 10 to 1 to 10 times longer than it is wide. Oumuamua had a similar elongation, which caused quite a stir. But 3I, Atlas, seems to have straight edges. In nature, We don't see straight edges at this scale unless there's been some very specific geological process. And this object hasn't been near a planet or moon where such processes could occur. It's been in interstellar space. The fourth anomaly is its temperature signature. When the James Webb Space Telescope turned its infrared eyes toward 3I Atlas in late October, it detected something extraordinary. The object has hot spots. Specifically, it has regions that are approximately 40 degrees Kelvin warmer than they should be given the ambient radiation and solar exposure at its distance. Now, 40 degrees Kelvin might not sound like much, but in the vacuum of space at that distance from the sun, it's enormous. It suggests either an internal heat source or some kind of active thermal management system. Let that sink in for a moment. Active thermal management. The fifth anomaly is its rotation, or rather, its lack thereof. Every natural object we've ever observed in space rotates. Asteroids tumble end over end, their rotation determined by the countless collisions they've experienced over billions of years. Comets spin, moons rotate. Even irregular chunks of rock ejected from distant systems should have some rotation. 3I, Atlas, appears to be maintaining a stable orientation relative to the Sunday. Its rotation period, if it has one, is so slow or so perfectly aligned with its trajectory that we can barely detect it. This is not how gravity and physics should work for a random piece of cosmic debris. The sixth anomaly was discovered only 3 weeks ago, and it's perhaps the most unsettling. The European Space Agency's Gaia satellite, which measures the positions and motions of stars with exquisite precision, detected a slight but measurable gravitational anomaly as 3I Atlas passed through certain regions of space. The object's mass, as calculated from its gravitational effects, doesn't match what it should be based on its size and spectral characteristics. It's too light, significantly too light. This suggests either an internal structure that's predominantly hollow or a composition that includes materials we don't typically find in nature. The seventh anomaly is electromagnetic. Radio telescopes from the Very Large Array in New Mexico to the FAST telescope in China have detected peculiar radio emissions from 3I, Atlas. Not constant broadcasts, nothing that screams artificial signal, but rather intermittent bursts of radio noise in frequencies that don't match any known natural process. Solar-wind interactions can create radio emissions, but 3I, Atlas, is too far from the sun and the frequencies are wrong. Cosmic ray impacts can generate radio pulses, but not with the regularity we're observing. And then there's the eighth anomaly, the timing. 3I Atlas entered our solar system on a trajectory that will bring it closest to Earth, just 0.3 astronomical units away, about 28 million miles, on December 19th, 2025. Then on January 9th, 2026, it will align almost perfectly with Earth, the Sun, and the centre of our galaxy. Now, in a universe of infinite possibilities, coincidences happen, but this particular trajectory, this specific timing, it's prompted some very serious scientists to ask very uncomfortable questions. Because here's what we know. If you were an intelligence wanting to study Earth, wanting to observe our civilization while remaining at a safe distance, this trajectory would be nearly optimal. You'd swing through the inner solar system, you'd pass close enough for detailed observations, and you'd do it at a time when you're partially obscured by the sun's glare from Earth-based observations. Whether this is a coincidence or something else, well, that's what tomorrow may begin to answer. Now, I want to be clear about something. I'm a physicist. I've spent my career studying the fundamental forces that govern our universe. I believe deeply in the scientific method, in evidence, in the principle that extraordinary claims require extraordinary evidence. And I can tell you that the vast majority of my colleagues, brilliant, rational people, would say that 3i Atlas is almost certainly a natural object with unusual but explainable properties. We've been surprised by nature before, we'll be surprised again. But here's the thing about science, it's not about what we want to be true or what we're comfortable believing. It's about following the evidence wherever it leads. And the evidence surrounding 3i Atlas is unlike anything we've encountered before. Professor Avi Loeb has been quite vocal, some would say controversial, in suggesting that we should seriously consider the possibility that this object is artificial. Not because we have proof, but because the accumulation of anomalies has reached a point where dismissing the hypothesis out of hand is itself unscientific. As Carl Sagan famously said, absence of evidence is not evidence of absence. Now, tomorrow's images, what should we expect? NASA's JUICE spacecraft, which has been uniquely positioned to observe 3i Atlas at close range, has been collecting high-resolution imagery since November 4th. The images being released tomorrow represent the closest, clearest views we've ever obtained of an interstellar object. We're talking about resolution on the scale of meters, possibly even better, depending on the distance during closest approach. If 3i Atlas is a natural object, perhaps some exotic form of nitrogen ice, or a fragment of a distant planet's crust ejected by a cosmic collision, the images should show us an irregular, weathered surface. We'd expect to see craters, fractures, the accumulated debris of billions of years travelling through space. We might see layering that tells us about its formation history. We'd expect randomness. Nature is beautiful, but it's fundamentally chaotic at these scales. But if the images show something else, if we see regularity, symmetry, surface features that suggest manufacturing or construction, if we see anything that looks designed, then we're facing a paradigm shift that makes the Copernican revolution look modest by comparison. Think about what that would mean. For 4 billion years, life on Earth evolved in isolation, believing itself to be alone. For thousands of years, humans have looked at the stars and wondered. We've sent out radio signals, we've launched probes carrying golden records with greetings from Earth, we've built enormous telescopes to search for signs of life around distant stars. And all that time, we've found nothing. The great silence, as Fermi called it, the eerie absence of any evidence for intelligent life beyond Earth. And then, on a Tuesday evening in October 2024, an automated telescope in Hawaii spots something that doesn't belong, something that travelled across light years of empty space to enter our solar system, something that appears to be observing us as we observe it. The implications are staggering. If 3i Atlas is artificial, and I want to stress that this is still a very big if, it raises immediate questions. Who sent it? When? Why? Is it still operational? Or is it an ancient derelict, a message in a bottle from a civilization that may no longer exist? Is it observing us or simply passing through on its way to somewhere else? And perhaps most importantly, should we try to communicate with it? This is where science intersects with philosophy, with politics, with questions about human nature and our place in the cosmos. Because if there's even a possibility that this object is artificial, then we're no longer alone. The universe is not empty. Intelligence has arisen elsewhere, has achieved technology sufficient for interstellar travel, or at least interstellar messaging, and has, for whatever reason, sent something to our cosmic neighbourhood. Some have suggested we should attempt to send a message to 3i, Atlas, radio transmissions, laser pulses, something to indicate that we're here, and we're aware of its presence. Others, including Stephen Hawking before his death, warned against revealing ourselves to potentially superior intelligences. If aliens visit us, Hawking said, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans. It's a sobering thought. But I would argue that if 3I, Atlas, is observing us, it already knows we're here. Our planet has been broadcasting radio and television signals into space for over a century. The atmospheric signature of industrial civilization, the spectroscopic fingerprint of pollution, of agriculture, of technology, is detectable to any sufficiently advanced observatory. We're not hidden. We can't hide. So what do the images tomorrow tell us to do? If they show a natural object, we'll learn something profound about the diversity of materials and structures that can form in other stellar systems. We'll refine our models of planetary formation and stellar evolution. We'll add another piece to the puzzle of how our universe works. And we'll continue the search for life elsewhere, knowing that this particular mystery has a mundane explanation. But if they show something else, then on November 19th, 2025, humanity will wake up to a new reality. We'll know that we're part of a larger community of intelligence in the universe. We'll have confirmation that the universe not only can produce life and intelligence, but has done so at least twice. And, we'll be forced to confront questions we've been asking in the abstract for centuries, but now with immediate practical urgency. What is the nature of intelligence? What forms can it take? Are we looking at biological beings, post-biological entities, artificial intelligence, something we don't have concepts for? How do civilizations that reach for the stars organize themselves? What ethics guide them? What do they want? What could they possibly gain from observing us? And here's perhaps the most profound question. What does it mean for us? You see, one of the great filters in thinking about alien civilizations is the question of whether intelligence tends toward cooperation or competition, toward peace or conflict, toward enlightenment or self-destruction. If we discover that another intelligence has mastered interstellar travel and uses that capability for observation, for learning, for peaceful exploration, that tells us something hopeful about the future. It suggests that it's possible to survive the technological adolescence we're currently experiencing, to navigate the dangers of nuclear weapons and climate change and artificial intelligence, and emerge as a mature civilization capable of reaching beyond our planetary cradle. Alternatively, if 3I, Atlas, is a probe designed for reconnaissance before some other action, well, that's a darker possibility, but one we must consider. But let me offer you a different perspective, a more optimistic one, grounded in what we know about the universe. The universe is 13.8 billion years old. Earth is 4.5 billion years old. Life arose on Earth almost immediately after the planet cooled enough to support it within a few 100 million years. This suggests that life might be common, the ingredients for life: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. These are abundant throughout the universe. The laws of chemistry and physics are the same everywhere. If life arose quickly here, it's reasonable to assume it has arisen elsewhere. But intelligence, that's trickier. It took 4 billion years for intelligence to emerge on Earth. And technological intelligence capable of astronomy, of mathematics, of building instruments that can detect distant worlds, that's even rarer and more recent. We've only been capable of sending and receiving radio signals for about a century. We've only been spacefaring for about 60 years. This means that in the grand timeline of the universe, we're infants. We're taking our first steps. We're just beginning to look around and understand where we are and what's possible. Now, if 3I, Atlas, is artificial, it was sent by beings who have been doing this for longer than we have, perhaps much longer. Perhaps they reached our stage of development millions of years ago. Perhaps they've solved problems we're still struggling with. Sustainable energy, peaceful coexistence, the colonization of space, the preservation of knowledge across vast timescales. And if they've survived that long, if they've reached a point where they can send objects across interstellar space to study other worlds, then they've demonstrated something crucial. It's possible to survive. It's possible to thrive. It's possible to become something greater than what we are now. That would be the most hopeful message we could receive. Not a transmission saying hello or providing technological blueprints or revealing cosmic secrets, but simply the evidence that intelligence can mature, can persist, can achieve a stable equilibrium with its environment and its technology. Because right now, in 2025, humanity stands at a crossroads. We have the capability to destroy ourselves through nuclear war, through environmental catastrophe, through any number of scenarios that keep scientists and policymakers awake at night. But we also have, for the first time in history, the capability to understand these risks, to model them, to potentially mitigate them. We can see the precipice. The question is whether we'll step back or fall forward. Evidence of another intelligence, even ancient evidence, even a silent probe that doesn't communicate with us, would tell us that it's possible to step back. It would give us hope. It would provide what I think might be the most valuable thing the universe could offer us, proof that the story doesn't have to end in self-destruction. So tomorrow, when those images are released, I want you to remember this moment. Remember that you lived through one of the pivotal points in human history. Whether 3i Atlas is natural or artificial, whether it's a chunk of exotic ice or a messenger from the stars, its discovery represents a milestone in our species' journey of understanding. We've gone from believing Earth was the centre of the universe to understanding we orbit an average star in an average galaxy among billions of galaxies. We've gone from wondering if planets exist around other stars to cataloguing thousands of exoplanets, many inhabitable zones where liquid water could exist. We've gone from speculation about extremophiles to finding life thriving in the deepest oceans, in the most acidic lakes, in the most radioactive environments on Earth, demonstrating that life is far more resilient and adaptable than we imagined. And now, perhaps we're taking the next step. Perhaps we're moving from wondering if we're alone to knowing, one way or another, what the answer is. Tomorrow's images will be analysed by thousands of scientists around the world. There will be debates, papers, conferences. The data will be scrutinised with unprecedented intensity. And gradually, over days and weeks, a consensus will emerge. Either we'll find a natural explanation that accounts for all 8 anomalies. And believe me, scientists are extraordinarily creative when it comes to finding natural explanations. Or we won't. And if we don't, if the evidence continues to point in uncomfortable directions, then the conversation will shift from could this be artificial to what do we do about it? I can't predict what tomorrow will bring. I can tell you that I'll be watching, along with colleagues around the world, as those first images appear on our screens. I can tell you that my heart will be racing, because regardless of what we see, it will be beautiful. The universe is beautiful. Whether we're looking at a lump of primordial ice or the handiwork of another intelligence, we're seeing something that has crossed the vast emptiness between stars to visit our small corner of space. And I can tell you this, we're living in a remarkable time, a time when our technology has finally reached the point where we can ask these questions seriously, where we can gather the data needed to answer them. Our ancestors looked at the stars and wondered. We're no longer just wondering. We're investigating. We're exploring. We're reaching out into the cosmos with instruments and mathematics and the combined intellectual power of our species. Whatever tomorrow brings, it's a privilege to be here for it. It's a privilege to be alive at this moment in history. It's a privilege to be human, to be conscious, to be capable of understanding our universe and our place in it. So watch tomorrow with wonder, but also with critical thinking. Demand evidence, question assumptions. Be skeptical of easy answers, whether those answers are it's definitely natural or it's definitely artificial. The truth, as always, will emerge from careful analysis, from peer review, from the methodical process of science that has served us so well for centuries. But also, allow yourself to feel the profound significance of this moment. We're attempting to answer a question that every human culture has asked. Are we alone? And tomorrow we may get our first real clue to that answer. The universe is vast beyond human comprehension. There are more stars in the observable universe than grains of sand on all of Earth's beaches. Around many of those stars orbit planets. On some of those planets, conditions may be right for life. And on some of those worlds where life arose, perhaps it evolved intelligence. Perhaps it built civilizations. Perhaps it reached for the stars. And perhaps, just perhaps, one of those civilizations sent something our way. A probe, a message, a sign that we're not alone in the dark. Tomorrow, we'll know a little bit more. And whatever we learn, it will change us. It will change how we see ourselves, how we understand our significance, how we think about our future. So rest well tonight. Tomorrow, we open a new chapter in the human story, and it's going to be extraordinary. Thank you.